All right, this next section we are going to talk about degrees and radians. Now, degrees should be really easiest to think in because that's what we have always talked about. So that should be review from geometry. Now, there is another way we can measure angles, and that is by radians. So to start with, this concept is a little bit hard to grasp just because we're not used to it. So a radian is really the ratio between our arc length and the radius of a circle. Now, when we're thinking about arc length, that is how far we're going on a piece of a circle. So let's think about the whole way around our circle. So if I'm starting here and I went all the way around, we would call that the circumference. And if we're thinking about a circumference, the circumference equals 2 pi times the radius. Okay. Now, just to make things nice and easy, I'm going to tell us that the radius is 1, which means if I'm using this as my example for the circumference, we would take 2 pi times 1, which would just be 2 pi. Okay. Now, if I wanted just a piece of that, so let's say that I just wanted to go halfway around, then my arc length, I would take this 2 pi and I would just divide it by 2. All right, so again, I'm going to write this over here. So this is 2 pi. And if I wanted just half of the circle, I would just divide this by 2. So that means that this would be pi. And let's say I wanted this part right here. So that would be a quarter of our circle. So or it would be half of a half, right? So I can take this and I can just divide that by 2. Okay. So again, those are the arc lengths that I'm talking about. So, and I know that my radius is 1. So to get the radian, we're just taking this arc length, so that pi over 2, and we would divide it by the radius, which would be divided by 1 in this case. So my radian would be pi over 2. Okay. So the best way that I can explain this is to think of a radian as how far you're going around, so part of your circumference, over the radius. Okay. And to keep things simple, we are just going to talk about it as a radius of 1. Okay. So keep this in mind. I'm going to go to my next page. So again, circumference of a circle, that was at 2 pi r. And again, we're saying that our radius is 1. So when we're thinking of our circumference, we're thinking of it as 2 pi. Okay. So just to kind of compare between degrees and radians, we know that there are 360 degrees in a circle. And if we are thinking about that, again, that circumference all the way around, so our radius is 1, that is going to be 2 pi. Okay. Now, half of a circle is 180 degrees, and half of 2 pi would be pi. Okay, so again, I'm just dividing this by 2 to get this one. Okay. In a quarter of a circle, I know that there are 90 degrees. Okay, so up here, this would be 90. So that's half of 180. So if I just take this radian and divide it by 2, that would give me pi over 2. Now, let's say I am at 270 degrees. How do you think we could figure out that radian? Okay. Well, at that point, we would just be adding. So I would have to take pi, that 180, and then I would add another quarter of a circle. So that means I would take pi plus pi over 2. Okay. So if I'm doing pi plus pi over 2, I would need a common denominator. So my common denominator would be 2. So if I think of this as 2 over 2, 2 plus 1 would give me 3. So this would be 3 pi over 2. Now I could take this even further. So if I go back up to this quadrant, so let's say that I wanted halfway between 90. So that would be 45. So in its radian, that means that I would have to take pi over 2, and then I would have to divide that by 2. So if I do some work off to this side here, so pi over 2, and I would be dividing by 2 because I want half of that. Now we know we don't divide fractions. Instead, we multiply by the reciprocal. So this would really mean pi over 2 times 1/2. And then we're just multiplying straight across. So this would be pi over 4. So that would be its radiant equivalent. Okay. Now again, I can take that further. So let's say that I wanted 30 degrees. Well, 90 would be, if we're comparing the 90 and 30, that would be a third of it. So if I am thinking of it as a third, so 90 divided by 3 gives me 30, then I would have to take pi over 2 and divide it by 3. Now again, we don't divide, so instead of dividing by 3, we're going to multiply by the reciprocal of 1/3. So then this would give me pi over 6. Okay. So for 30 degrees, the radiant equivalent would be pi over 6. Okay. Now I could keep going. I could add in 60 degrees here. And if I'm trying to figure out the radiant equivalent to that, well, if I'm looking at 30, I could just double 30 to get to 60, so I'm allowed to do that with my radiant. So if I have pi over 6, and I'm trying to double it, that means I would take it times 2. So then this would be 2 pi over 6, which I can simplify then to be pi over 3. And we can keep doing that, doubling, having, comparing, but that gets really long and tedious. So we want to be able to come up with a nice conversion ratio to go from degrees to radians. Okay. Now again, when we're looking at this, we're looking at its equivalent degree and radian. So we started off with 360. We used the circumference formula to come up with this 2 pi, because remember our radius is 1. So that means 360 degrees is equal to 2 pi for radians. Okay. So if we cut 360 in half, that gives me 180. And again, if we're doing the same thing to its radian, I'm just dividing 2 pi by 2, and I'm left with pi. So pi and 180 are equivalent degrees and radians. So those things mean the same thing. Okay. So we are going to use that idea to just come up with a nice simple ratio that we can use every time. So when we are converting between degrees and radians, we're going to use this one because it's a simplified version of this. So pi over 180. Okay. So anytime we're going from degrees to radians, we're going to multiply by pi over 180. Okay. And when we do the opposite, so if we're going from radians to degrees, we are going to multiply by 180 over pi. Okay. So just to do some practice of that, and some of these we actually already have the answers to from that previous one. So here we are going from degrees to radians. So if I'm doing that, I'm going to multiply by pi over 180. Okay. So the idea is, so this is 180 degrees, is that we're getting the labels to cancel out. So if I have degree and degree, those labels cancel each other out, and I would be left with radians. And usually the short version of radians is rads when we write it. Okay, so think about your science classes and how you do your conversions to get the labels to cancel out. So it's the exact same idea when we're converting between degrees and radians. So when we do that, we're just going to multiply straight across. So this would be 30 pi over 180, and then we want to simplify that. So we don't need to make it difficult on ourselves. We can grab our calculator we'll just simplify the fraction. So we want to focus on the 30 over 180. So I'm just going to do 30 divided by 180 on my calculator. And I'm just going to change it back to a fraction. So to do that, remember we're going to press the math key. And then that first one means fraction, so we're going to do enter, enter. Okay, so 1/6 would be that simplified fraction. So 30 degrees is the same thing as pi over 6 for radians. And then we just keep going. So for the 240, again, I'm taking it times pi over 180. And I'm going to simplify using my calculator right away. So I'm going to do 240 divided by 180. Change it back to a fraction. So this will be 4 pi over 3 for the radians. And if we have a negative degree, still the exact same idea. So I'm still going to multiply by pi over 180. This time when I type it in, I need to make sure I use my negative key. So negative 60 divided by 180. Change it back to a fraction. So my radians would be negative pi over 3. So it's okay to have negative radians just like we have negative degrees. Okay, so go ahead and pause your video, do the practice on the next 3, and keep in mind if the fraction doesn't simplify, then you just write it out. Okay. Now if we go the opposite direction, where we're converting from radians to degrees, we're going to multiply by the opposite. So this time I need that pi to cancel out, the radians to cancel out. So we're going to multiply by 180 over pi. So then the pi's cancel, and now I have 180 divided by 3, and we're just simplifying that. So if we actually do that division, that would give me 60, and I need to make sure I label it with my degree symbol. Same thing on the next one, even if it's negative, we are still multiplying by 180 over pi. Okay, so the pi's cancel. So this time we're going to be, multiplying straight across, we are taking negative 7 times 180, and then we would divide that by 4. So this is going to be negative 315 degrees. All right, so again, pause your video, go ahead and do C, D, and E, and those answers will be on this sheet when you check the class notes. Now, I'm going to skip down to F, so just so you guys can see this one. Now, we have been told that this is a radian. So I know I said that we're trying to get the pi's to cancel out, but if the pi's in the denominator, there's probably nothing that we can do about that. So we still have to multiply this one by the 180 over pi. So when we do that, again, we have to go straight across. So we are taking 22 times 180, so 3,960, and then pi times pi is the same thing as pi squared. Okay, so we're thinking of it like variables. So I need to simplify this part. So to do that, we would do 3,960. We are going to divide it by, and then on your graphing calculator, your pi symbol is above the caret key right here. So I'm going to press second and then the caret key, and that gives me the pi symbol. And then I'm just going to use my squared key to square it. And then I'm going to press enter. So the degrees for this one is approximately 401.2 degrees. Oh wait, nope, sorry, it says nearest hundredth. Make sure we round correctly. 401.23 degrees. So this would be my final answer for that problem.